So it's time to look at the outcome, right? We have here the net CO2 emissions with net negative emissions at some point. So if you want to stay with RCP 2.6 beyond a certain point, with all the scenarios used for science and technology and energy sources and population growth as well, then you will have to begin to take out carbon out of the system to reach RCP 2.6 by the end of the century, which means you will not go completely carbon neutral. There will be many things that will be emitting carbon: transportation, agriculture, energy production, buildings, whatever. But you will have to find carbon capture and sequestration methods to take out carbon and reach net negative global emissions. Okay, so basically you have to take out more carbon than you are putting into the atmosphere. And there are multiple models run. Why? Because each country now has models. US has, I don't know, maybe 4 or 5 models. China has 4 or 5 models. Europe has several models. India has produced a future scenario now for the first time. These are called CMIP, coupled model intercomparison projects. Long story, but for this case you just think multiple models are providing multiple scenarios, and you can see that RCP 8.5 here takes us to a warming of 3.2 to 5.4 degrees centigrade relative to 1850 to 1900. So a different baseline is used here than usual. The net CO2 emissions associated with that will be more than 100 gigaton CO2 per year. We are already about more than 40, I think. It depends on whether you do it as CO2 or carbon. There is a factor of conversion of 3.7 or so between carbon and carbon dioxide. You can also do carbon dioxide equivalent, as you can see here, which includes other greenhouse gases like methane and nitrous oxide and so on. Okay, so this 8.5 included 172 scenarios of various energy productions, transportation options, population levels, and so on and so forth. And you can see similarly there are different number of scenarios being run here. And the RCP 2.6, if you want to stay in the range of 2.7 to 3.7 degrees, some scenarios will allow you to continue to increase the carbon emissions, because that includes carbon capture and sequestration, I think. And if you want to do RCP 4.5 with this range of temperature change, then you come down here and so on. So basically this is kind of a movie making, but these are supposed to give you a number of choices. Who plans out to 2100 based on these model outputs? Not very easy to say, but military, for example, can plan things out to this time scale. Why? Because let's say there is a navy that wants to build a big port that can take much bigger ships at the port. Then they want to build a port with sea level in mind. So this warming scenario is going to determine the sea level rise at a particular place, like let's say Norfolk in Virginia where there is a naval base, or San Diego in California where there is a naval base, and so on. I'm just picking the US because US is a country where climate change is not easily accepted, but the military defense is taking it seriously anyways. Okay, so if you want to plan, let's say out to 2030, which is right around the corner, we are already in 2020, so you cannot really ignore what will happen by 2030 in terms of energy changes, impacts of warming on physical systems, biological systems, human managed systems like food production, right? Health. So these things do matter, so people do have to take them fairly seriously. So cumulative total anthropogenic CO2 emissions from 1870. Remember, what matters is concentration, residence time, and global warming potential. So we haven't looked at global warming potential, but you can look it up. CO2 is considered to have, let's say, global warming potential of 1. That is how much warming it will cause for each ppm increase. Then you can, over a certain time, and you can compare methane, nitrous oxide, CFCs, HFCs, and so on to CO2. And you will find on Wikipedia and elsewhere that methane, for example, is 25 times as potential as CO2 in terms of global warming over a period of time prescribed. N2O is maybe 200 times, and HFCs are, I think, maybe 2,000 times. But CO2 residence time is 200 years or longer, whereas N2O can remain much longer. Methane is only 10 years. HFCs can be a couple of thousand years. So concentration, global warming potential, and residence times matter. If residence time is a couple of hundred years for CO2, that means once it's emitted, it's going to stick around, which means it keeps accumulating over time. So you start here in 1870, and you see how CO2 has increased out to 2010 when this graph was made, I think, and then future projections are made. And you can see that the cumulative CO2 keeps increasing, and based on the temperature anomaly, there is almost a linear relation between increase in cumulative CO2 and temperature increase. That is used often to say how much CO2 we have left to emit to control global warming to 2 degrees or 1.5 degrees or so. And then look at the emission rate per year now, let's say in 2020, and try to estimate how many years we have. But that's kind of not a very good idea, because many people say we have only 10 years left to save the world. These are very misleading, so don't believe in those, okay? That was started by the UN Secretary General, I think, but you will find a lot of papers talking about why this is not a good way to talk about CO2 emissions and remaining time to save the world and so on and so forth. Okay, nonetheless, you get a good sense of the nearly linear relation between cumulative carbon and global warming. It does give you a good handle on how to plan for the future. Okay, some game changer has to come along, which will probably begin to take out the carbon from the air and hide it somewhere. So you can see that there are ranges of various scenarios from 2.6 with 1% CO2 range per year, and so on and so forth. So various combinations are used to produce these envelopes, and these are called what if scenarios. So if you want to plan for the future, you don't bet based on only one thing. You look at the possible scenarios you have to deal with in the future, whether it's building a dam, planning for energy, planning for food security or military, national security, whatever. Okay, so let me stop this here and continue the other 2 slides in the next podcast. Okay, so RCPs are used to project global warming and emissions per year and atmospheric CO2 concentrations. We have to track all those things.